So let's talk about how to solve equations in quadratic form by substitution. So what you're going to do is you're always going to define a temporary variable u based on the relationship between the variable expressions in the given equation. So you substitute u back into the original equation. You're going to solve the quadratic equation obtained from step 1, either by factoring, completing the square, or using a quadratic formula. In the two examples in the last video, I was able to do that by factoring. Once you solve for u, you replace it with the expression you defined in step 1, and you solve the resulting equations for the original value. And then, of course, you always need to check your solutions just to make sure you didn't make a mistake and everybody's included. So let's work through a couple more examples, and then I think we'll be in really good shape. So I have this problem repeated twice, so I skipped it once. So I have x squared minus 4x squared is negative 2. So the first thing I need to do is get this into a standard quadratic form. So I'm going to move that 2 over to the other side. So I'm going to have x to the 4th minus 4x squared plus 2 equals 0. And then I'm going to go ahead and define my u. In this case, u is going to be x squared. So that would mean my first term, which I could have rewritten as x squared minus 4x squared plus 2 is 0. Now I have u squared minus 4u plus 2 equals 0. And this is u substitution. And if you have to take pre-calculus or if you have to take calculus, you are going to see this again, I promise you. So I have to factor this. So I say, what are the factors of AC that add up to B? Well, there aren't any, so this means I'm going to need to either complete the square or use the quadratic formula. You know what I'm going to do? I'm going to complete the square. So I'm going to go ahead and subtract 2 again from both sides, right? Because the first thing we want to do when we complete the square is make sure our leading term is a 1, which it is. Then we want to isolate the constant on the other side of the equation. Next, we want to add our middle term divided by 2 squared to both sides. Remember, what I do to one side, I've got to add to the other side. That gives me u squared minus 4u plus negative 4 divided by 2 is negative 2. Negative 2 squared is a positive 4. This is going to factor to u minus 2 squared is 2. So I have 2 plus 4. Then I'd go ahead and take the square root of both sides. So I have u minus 2 equals plus or minus the square root of 2. I'm going to add 2 to both sides. So I have u equals 2 plus or minus the square root of 2, and then I have to substitute that back in for x squared. So I have, let's switch to green so I can write it over here, x squared is 2 plus or minus the square root of 2. We take the square root of both sides, which we can do, and I get x equals plus or minus the square root of 2 plus or minus the square root of 2. And this may look really odd, this double square root, but I promise you it is mathematically legal. So your answer is complete. Next, I have 5x plus 3 squared plus 9x plus 3 squared is 2. So my u is going to be x plus 3. Let's move this constant over. So I have 5u squared plus 9u minus 2 is 0. So what are the factors of AC, which is negative 10, that add up to 9, which is B? Well, that would be negative 1 times 10, because negative 1 plus 10 is 9. So I have 5u squared plus 10u minus 2 is 0. And then we factor by grouping. The greatest common factor of 5u squared and 10u is 5u. So I have 5u times u plus 2. The greatest common factor of a negative u And a negative 2 is going to be negative 1. Remember, we never like negative leading coefficients, and I need both of these to look the same. So I have 5u minus 1 is 0, and sorry, I skipped a step. So we collect the greatest common factors they had in common. I have 5u minus 1 times u plus 2 is 0. So 5u minus 1 is 0, u plus 2 is 0, u is negative 2. I add 1 to both sides, and then I divide by 5. U is 1/5. Now, u isn't u. U is x plus 3. So I have x plus 3 is 1/5, and x plus 3 is negative 2. So I get x is negative 5. If I rewrite 3 so that its denominator is 5, that gives me 15/5. So I'm going to subtract 15/5 from both sides. So I get x is negative 14/5 and x is negative 5. Those are my two zeros for this equation.